So, okay, let's start. So, my name is Sébastien Gérard. I'm part of the CEA. I will explain a bit what is CEA. It's an acronym for French Agency of Atomic Energy located in France. The purpose of the talk will be to speak about Papyrus, and I will give you a bit of history about Papyrus, why we do Papyrus at the CEA, what we decide to work on that, to say you where we are, and what is the next plan related to Papyrus. So first, it is sure start today with respect to what we do in software engineering or in software intensive system. There is a lot of failure, so a lot of waste of money, a lot of waste of time. You can Google on the internet, you will find a lot of papers that give you some example of system who has failed. There's a lot of millions of dollars that are lost due to systems, or mainly to do software failure in systems. Either it is the software which is embedded in the system, or it may be failure for the software that are used to build the system, but there is something wrong with software engineering. So the rationale for this failure maybe are that all the systems we are building, that are built today on the world, are more and more, of course, complex. And engineers who are working on designing this system have to face to a lot of constraints which are not going in the same direction usually. So they have to go faster, they have to make it with less money, they have to provide higher productivity, higher quality, and so on. So there is a mismatch between the constraints the engineers have to fail. And so the traditional method we are using, either at the system engineering level or software engineering level or even at hardware engineering level, are no more adequate for dealing this system who are increasing in size, increasing in complexity, and so on. So there is a need to go indeed to craft engineering, to more professional engineering. And one of the ideas, as it was already well introduced by Manfred this morning, is that the use of model-based engineering seems to be one of the paradigms that could be very useful and could provide good answer to solve some of the issues. Second point is that the usage of standards seems to be also a very important point for the industry in order, as for example, to reduce risk and to reduce cost to use non-standard technology or methodology. Standards are very useful because they first facilitate communication between engineers who are involved in team. And today, one of the complexity we have to face when we design system is that because the systems are bigger and bigger, we need more people to work on the system. There are more and more concerns that are involved in designing a system, like performance, which is usual, safety, security, and so on. So we need different persons with different expertise to work together on a system. So communication is a key point in the design. Of course, these people are using different tools, so they need to, all these frameworks need to interoperate, and they need to interpret with respect to this syntax. But the semantics issues are very important, so it's very important to be able to use standard for that purpose also. The usage of standard also will foster the development of the tools themselves and the complementarity tools to be developed. And then it also provides some, it's a very useful background to provide for the industry to define best practice. They can define generic best practice that can be reused across the different units, as for example, of their industry. It encourages also the development of process and method based on standard. And also because we can use standards, we can benefit of education materials that may be developed on top of the standard. And finally, one of the key issues is also to be able to not be vendor locking by some tools. So there is a very important focus for the industry also, so to be model-based engineering and to use standards. In this context, there is an organization called OMG, which is OMG Object Management Group, which is an international organization who has provided, who have defined almost 10 years ago a standard called model-driven architecture. And this standard is indeed a bundle of standard focused on providing facilities for enabling modeling in the industry. And as for example, we get in the standards, in this MDA, we get UML, SysML, QVT for transformation, BPMN for process modeling, and so on. The last introduction slide is about the usage of UML. So UML is a unified modeling language, which was defined around 2000, I think. So it's come to be a well-established language now. It's international, popular in use. And there is, as I said, for the standard itself, there is a lot of interest to use UML. First, because it is educated, disseminated everywhere in the world. So you get engineers who know about UML with certain level of expertise, of course. But there is at least a bit of knowledge on UML. So you don't start from zero with respect to that purpose. Second part, which is also very important, is that UML can be considered also as a pivot language. So you can use UML because UML is not a language. UML is a set of languages. And he defined a framework that compose this kind of language. So you can use UML as a pivot language for integrating several concerns like design of your system, requirement, and so on. So as I said, it's a modeling language. So it provides mean to model structure, automate, interaction, action, and so on. It covers a lot of needs. And in fact, it's the result of a lot of experience because maybe you know, but UML was built integrating a lot of modeling technology that was provided in the 90s with a lot of very guru guys in that domain like James Rambo, Bush, Jacobson, Brand-Sedic, and so on. And UML has been defined as a generic language, but UML is suitable to be extended via a concept of a profile. So using this concept of profile, you can create on top of a framework, on the UML framework, you can create your domain-specific modeling language. And there are two examples which are also part of the standard at the UMG, as such DSL, which are SysML, for system engineering, or MARTI for modeling and analysis of real-time embedded system. So just a very short point on what is the CEA, because some of you may be afraid by the A of the CEA. So CEA means really it's a French government institution for working on atomic energy. So it's one of the major actors in research and innovation. It's about 16,000 people located in France, and indeed it consists of 4 divisions. One which is dedicated to science, pure science. One which is dedicated to defense and security. One which is very focused on energy, nuclear energy, and one where I am working, which is dedicated to technology engineering, technology for any domains, except, in fact, nuclear activity. Okay, so the idea was several times ago to try to apply all the technologies that was developed for energy, for nuclear energy, to other domains like avionics, automotive, and so on. So this division is about 6,000 persons located mainly in Grenoble and in Paris. And the work of this division, called CEA Tech, is to work on innovation, innovation and technology transfer. So for that purpose, we are working mainly, they develop this kind of pattern strategy, which is we make publication, patent, prototype, and product. So if we consider the maturity level that was defined by SEI, So we go from what they call TRL 3 to TRL 6 or 7. So that means that we go from research, not fundamental research, but research, until prototype, just before it becomes real product. And at that time, we have some dedicated partnership with industry to go from the prototype to the real product. So we have two kind of labs called innovation labs. So we have academic innovation labs for upstream research. So for the TRL before 3. So as for example, we have two innovation labs. So one which is already set, which École Centrale on formal modeling, and one which is under building with CEPELEC. And we have 3 innovation labs at the industrial level. We'll come back later on these 3 innovation labs. One with STRL technology, one with Sherpa engineering, which is working mainly in automotive domain, and one which with All4Tech, which is working on safety analysis. So on the list, which is one of the subdivision of the CEA Tech, where I am involved on where we are very focused on system and software engineering, is located in Paris, or south of Paris, 20 kilometers south of Paris, and it's about 700 people working on that subject. So the labs I'm leading in this list institute is very focused on model-driven engineering. So we are working on model-driven engineering for the design of cyber-physical system. And we try to define generic technology, generic methodology, dedicated, and then to implement, to instantiate all this generic technology for specific domain like automotive, railway, avionics, robotics, and so on. So in this context, the main focus of the team is to define methodology and tool for the methodology, because a methodology without tool doesn't mean nothing. So we define the tool that are needed to support the methodology to develop complex and safety critical cyber physical system. So our main choice was to use object-oriented paradigm to provide extension dedicated to real-time domain, like as mentioned by Manfred, how to model the time, how to model the memory, how to model the energy, and so on. So by the way, in this context, we have standardized the MARTI standard. We have done the MARTI standard at the UMJ. We use UML as a foundation of that framework, and we try to be active to standardize all the concepts we want to define. So to standardize, as we do for MARTI, and also to make to provide a reference implementation, because if you have only paper standard, also again it doesn't mean anything. So each time we make a standard, so we promote a standard within a dedicated organization for that purpose, so MJ, ISO, and so on. Then we also try to make a reference implementation of that standard. When we start to work on that subject, so that the LEAS laboratory is existing for more than 20 years now, the idea was not to build a UML tool. In fact, the idea was to reuse a UML tool. So 20 years ago, there was no UML tool. We were using class relation, another paradigm which was similar to UML. And when UML was designed in 1997, we jumped to UML, and we consider it would be the de facto language for modeling. So at that time, the idea was to provide extension to the UML tool or modeling tool dedicated to that specific concern of real time. The advantage of that strategy was that we can rely on the fact that there was an industrial support and maintenance for the tool we were using. The advantage, the drawbacks, was that there was mainly these 4 issues. So first, all these tools were not really conformant to the standard anyway. Second one is that it was very difficult and more difficult 15 years ago to in fact complete such a tool, because the API, such of this tool doesn't have any API at that time, and was very close in fact. So it was very difficult to define and to implement add-on to this tool. It's easier now because more and more they provide API or they are an open source part and so on. But 15 years ago, it was not so like that. The concept you are using is to use the concept of profile and the concept to extend UML. And at that time also, profile implementation was very limited. As for example, no CL support was provided. There is no mean to adapt the syntax of the language. It was possible to use profile to define the abstract syntax of the concept, but the syntax, what the user is seeing, I call surface syntax or notation, was not possible to be adapted. So the result was very, in fact, frustrating. And moreover, which is a very important point of view, each tool, in fact, behind each tool there was a methodology that was underlying. In fact, Rational has its own methodology, Gentleware for Poseidon has also a methodology. So the methodology was indeed hard-coded in the tool. So the tool was dedicated to the methodology. So in your company, if you wanted to define a methodology which was not aligned with the one in the tool, you can't make it. In fact, you have to twist your methodology to fit the possibility of the tool. So for this reason, we decide to make a UML tool and to provide such a feature. So why we decide also to make it is, in fact, it is because in the context of this work on profile, so we decide to make a tool to assist the user to make a profile and to be able to deploy, as for example, automatically the profile onto RSA or ROS at that time, Poseidon, and so on. So in fact, we start our first experiment to implement a tool. I have to say that. So at that time, we were very academic, and we try we get our first experience designing a tool for that purpose. So we try different technology, and then we say, okay, it seems it's feasible to make a tool. At that time, we don't see all the work that was needed, in fact, to make a real tool. But it was the first start. We say, okay, why not to make a UML tool in order to overcome all the drawbacks I just listed in the previous slide. And then we make a first version of the tool. And so it's almost 10 years ago. We decide also to make it open source because for several reasons. In fact, there was already a large offer in terms of commercial tools with different business models. Some was cheap, some was expensive. So for us, it was we didn't see any place for a new commercial UML tool at that time, or difficult to be done. On the open source side, it is very often the case. The offer was very, in fact, scattered and very incomplete. There was people who was providing a tool for class diagram edition, some for sequence diagram, but no one was providing a full and complete tool, very efficient and very usable. So we decide to make it on our side. And the expectation of the CEA with respect to this initiative was to be able to define a core technology and a sustainable core technology, and to be able to benefit, because we develop the tool today, but we also work very hardly to develop a community, an ecosystem around the tool, in order to be several people contributing to this tool. And for that purpose, as for example, we are very involved in the academic domain, working in the Models Conference, in all these activities. So we wanted also we expect also to be able to benefit from the ecosystem that could be set around the tool. And it was, as I said it previously, it was a means to support our standardization activity by providing an open reference implementation of what we standardized. So we have two versions of Papyrus. So the numbering is a bit strange, but it's mainly due to the Eclipse, in fact, rules that when you start an Eclipse project, you have to have a version minor than 1. But before being in Eclipse, we have a version of Papyrus already. So this was a 1.x version developed between 2007 and 2010. It was mainly the CEA and a university called l'EFL in Lille in France. Technology was mainly Java, EMF, Jeff. So it was mainly uncoded, I would say. And there is some committers from CEA, and one from l'EFL. In the meantime, in fact, there was also another initiative called Topcase that was developed and promoted by Airbus in the south of France. So for some reason, political reason, strategic reason, at that time in France there is a lot of activity and strategy activity. So these two initiatives was driven in parallel, I would say, without really communicating. And there was two environments. So Topcase, the scope of Topcase was larger than the scope of Papyrus. Papyrus was dedicated to provide support for UML and UML profile for modeling. And the scope of Topcase was to provide an open source framework for designing critical embedded systems. So that was also involving requirement engineering, code generation, verification, and so on. And within this context, they have also they also made UML and a SysML tool. So after some time, in 2010, we succeed to agree, and we make a convergence to make a new version of the tool. And in the meantime, we decide to go to the foundation and to become a profile, a UML, the UML tool of the foundation. There was already a UML tool in the foundation that was mainly supported by Borland, but at that time Borland was reducing, in fact, its activities. There was not really, there was no more really activity behind that tool. So it was a good time also to replace that component, to make an upgrade of that component inside the foundation. So we make a proposal. So for the technology, we are still Eclipse, of course, Java, but we were also using GMF runtime, and GMF-T, which is GMF tooling for the generation. So we started to introduce model-driven techniques inside the development of Papyrus also. The list of committers is also become larger, so there was people of CEA, and as you can see, more and more people of CEA, so marking the involvement of CEA. Athos also, because there was, while there was also involved in the Topcase, so we merged the committer of both projects, and some individual, Cédric Dumoulin, from l'EFL, and Christian Damus, who is a guy who is also well known in the Eclipse community on the modeling project. I don't know where I am in the time. So where we are now. So we have provided the 1.0 version. That means that we leave the incubation stage this year from the Eclipse Foundation. And the work for the last year was, in fact, focused on improving usability, improving robustness of the tool, and improving performance of the tool. And finally, to improve customizability of the tool. So this last point is related to the ability of Papyrus to support profile, and to provide you ability to make a DSL, but based on a UML profile. So the year has been very focused on these 4 main features, and all these features has been mainly worked and validated by within a close collaboration with Ericsson, which is one of the more important supporters of the tool for now. And and with respect to the standards themselves, so we are conform to the UML 2.5 standard, which is the very last update of the standard, because it's not really yet publicly available. It will be at the end of the year. We cover all the diagrams that are defined in the UML2 specification. With respect to SysML, we are a bit late. We are only conform to SysML 1.2, while the standard version is 1.3, and they plan to provide a 1.4 for the year. However, we provide all the viewer, so that means all the graphical editor and all the table-based editors that are defined in the standard. We plan to be conform to 1.4 by the end of the year, normally. And we provide also a support to the Marty 1.1 version, which is the current version of the standard. With respect to the Papyrus deployment, so Papyrus is deployed now for some time, for several years, in a lot of European projects and national projects. This is an extract of the list. As for example, OpenETCS is a large European project dedicated to set up a framework of open source tool for the railway domain, and Papyrus has been chosen as the modeling tool. The cluster connection is a French project which is focused on, in fact, providing new technology, new method for designing the control command system of the next generation of nuclear plant, where you have the main French actors, EDF, Areva, involved inside. Papyrus has been also chosen as the modeling tool for that project. And another example, which is the Romeo project, which is a French research project where the Aldebaran company is also involved. Maybe you have already seen the Romeo robot, which is a humanoid robot. And so the project is focused on system engineering and safety analysis, and Papyrus has been chosen also to describe the system model of the Romeo robot. And if you go to internet to all these sites, you will see. So I come back on the innovation labs you have set up in the CA. So this the Listerel labs. So this labs was set up 4 years ago now, 5 years ago now. And the purpose of the labs was to complete the STRL offer in terms of tool with a system tool, in fact, use those tools to enable to model system. And they make the choice to use Papyrus as a kernel for their tool. And so now they provide a SCAD system designer tool in addition to their tool set, which is in fact a customization of Papyrus embedded in their framework. The second labs you have with Sherpa, focus on control engineering in the automotive domain. Also provided a tool dedicated to model system or control of the automotive, which is also based on Papyrus. And finally, All4Tech, so it's a 2 years labs, is providing their new version of safety architect based also on Papyrus. So there are also already, in addition to the 1.0 version, which is used in a lot of projects and industries, there was also a company who are building their new solution on top of the Papyrus solution. So just that, it's a set of testimony of people who have chosen Papyrus. As for example, ST Microelectronics also is building his tool for designing on-chip system with based on Papyrus. Or Spacebell is a Belgium company who is working for CNES, and which is designing a satellite system using Papyrus. So last point is about, so once you have make a model, it's good, you have a model, but behind the model-driven engineering, there is the idea to use the models. So it's very important to be able to denote a model, to denote the information, but the information has to be useful. So we need to be able to use the information. And we need to be able to use it to help the engineers to use them. So not only to be able to make a mental-based model analysis, but to be able to make computer-aided model analysis, to put additional tools in the loop that will enable the user to exploit the information in the model. So it's just an extract of some of the features we have added on top of Papyrus. So Papyrus is dedicated to model the information, but you have also complement that are dedicated to exploit the model. So as for example, we provide also within Papyrus, a Mocha framework, which is dedicated to make execution and simulation of your model. You have a tool to make safety and security analysis called Sophia. You have a dedicated platform for robotic system engineering, which enable you to design the robot and to generate code for simulator of a robotic system. And we have also some tools we are dedicated to real-time modeling analysis and code generation. So, and if you want more information on all these tools, you have a booth and you can visit, and there is demonstration and people around all that tools that can give you more information on all these subjects. So what next? First slide is to just say you that CEA at the corporate level, you have the support of the CEA for continuing to work on Papyrus. So it's very important to note that the CEA itself has confirmed their activity in software technology for the further year. And the list institution, has put Papyrus as a major artifact of its strategy for promoting technology into the industry. In terms of roadmap, for the next version, so the version that will be available in the Mars Eclipse platform, we are going to still focus on usability, robustness, performance, and customizability. As for example, for robustness, we are continuing to work on testing Papyrus. So we mainly make put the focus on be able to generate automatically the test from the Papyrus design in order to be able to improve the regression validation of Papyrus and to improve this robustness. Performance is a key focus, and customizability also will continue to be improved. Some new topics will be worked on. So we will provide an extension of Papyrus to support UML-RT, which is an extension of UML for real time. This is one of the main targets of Ericsson this year, to provide a real support for UML-RT. And in fact, maybe you know such tools like RSA, RTE, Rhapsody, as for example. The idea is to provide at least a minimal functionalities comparing to this tool. There is a language called ALF, which is a complement of UML dedicated to action specification. So we will provide also complete support to that. And there is a standard called diagram definition at the UMJ, which is enabled. So today you have XMI, which enable you to exchange model information. And the diagram definition standard should enable you also to exchange the graphic information. And we will provide a support for diagram definition. Finally, open source is very important. So we try to also, as I said, make an ecosystem behind the open source community. And so there will be a workshop at the Models Conference dedicated to that subject. So you are very welcome to assist to this workshop. That's all. I hope I am on time.